All right, welcome back to part 2 of 2.1, the definition number 2, right triangle trig. Okay, so we left off on this here, this cofunction theorem. Okay, so let's take a look at some of those special right triangles. Let's start with the 30, 60, 90. Okay. All right, so continue taking notes. Okay, so the 30, 60, 90. Okay, so if you recall from Unit 1, when we did special right triangles, we said, okay, well, if you had the 30, 60, 30 there, 60 over here, okay, it turns out that this side, if this side is x, the hypotenuse is going to be double, and this leg over here is going to be square root 3x, okay? Now, for simplicity, let's go ahead and let's let x equal 1. Okay? And if that's the case, then we have the following lengths for the sides. We have 1 over here, we have 2 over here, and we have square root 3 here. Okay? So, now, using this triangle over here, let's go ahead and find sine. Let's go ahead and find sine of 60 degrees, cosine 60 degrees, and tangent 60 degrees. Okay? All right, so sine 60. Sine of 60, here's 60. Sine is, if we use SOH CAH TOA, opposite over hypotenuse, so that's going to be square root 3 over 2. Okay. Cosine 60, cosine SOH CAH TOA, so that's adjacent. Here's 60, adjacent over hypotenuse, so that's 1 over 2. And tangent 60 degrees, tangent SOH CAH TOA. So tangent is opposite, square root 3, over adjacent, which is 1. So that's just square root 3. Okay? All right. These need to be memorized. Okay? So absolutely memorize this, or these. Okay? And try to memorize them ASAP, as soon as possible. Okay? Okay, let's take a look at, since we have 30, 60, 90 triangle, let's now find the sine of 30, cosine 30, and the tangent of 30. Okay? Alright, starting with the sine of 30 degrees. Sine is SOH CAH TOA, so opposite over hypotenuse. Let's take a look up here. Here's 30 degrees, so opposite 30 is 1. Hypotenuse, 2, so 1 over 2. Sine of 30 is 1 over 2. Which makes sense with the cofunction theorem, right? 60, 30, 60 and 30 makes 90, and we said that cofunctions should be the same, right? Cofunctions of the complement. Okay, so that makes sense. All right, let's do cosine 30. Well, based on that, cosine 30, we don't even have to look up at the triangle. Cosine 30, cosine is cofunctions with sine. These are complements, 60 and 30. So cosine 30 should be square root 3 over 2, right? Well, let's check on the triangle. Cosine 30. SOH CAH TOA, so cosine is adjacent over hypotenuse. Here's 30. Adjacent is square root 3. Hypotenuse is 2, square root 3 over 2, which is what we said over here. Okay? And then tangent 30, we do have to look at the triangle. So let's take a look. Tangent 30, SOH CAH TOA, so opposite over adjacent, 1 over square root 3. 1 over square root 3, another way to look at that is if you rationalize the denominator, we get square root 3 over 3. Okay? Alright, so just like 60 degrees, sine, cosine, tangent of 60 degrees, I want you guys to memorize ASAP. Okay? Okay, and then let's take a look at the 45, 45, 90 triangle. Okay, so let's take a look. 45, 45, 90 triangle. Alright, and let's recall what we had in Unit 1. Okay, so these two were 45, and we said, okay, then that means these two are going to be the same, and this here turns out to be 2 times square root x. Okay, 2 times square root x. Okay, so just like up above, for simplicity's sake, let's let x equal 1, and if we let x be 1, then I have these measurements. I have 1 here, and square root 2 over here. Okay, so we're going to go ahead and use this triangle, the one on the right, this one, to come up with sine, cosine, and tangent of 45 degrees. Okay, so find sine of 45 degrees, cosine of 45 degrees, and tangent of 45 degrees. Okay, all right, so starting with sine. And it doesn't really matter which one you use because they're both 45. So let's just use this one. So SOH CAH TOA, sine is opposite over hypotenuse, so 1 over square root 2. But if we rationalize the denominator, we get square root 2 over 2. Okay? Cosine of 45. Cosine of 45 will be the same because they're cofunctions of complements, right? So this one will also be square root 2 over 2. And we do see that because cosine is adjacent over hypotenuse. So adjacent would be 1 over square root 2, which is the same. Okay? And then tangent of 45. SOH CAH TOA. So tangent of 45 is opposite over adjacent, 1 over 1. So tangent of 45 is just 1. Okay, here. 1 over 1, which equals 1. All right, so these also need to be memorized ASAP. Okay? Okay, so when you see problems and they ask you to find the exact value of sine of 45 degrees, right? So when they say find the exact value, they want your answer in radical form, okay? So if they don't say exact value, then you can use your calculator and come up with some decimal answer, okay, like 0.724, okay? All right, so let's take a look at this example here. Use exact values. So that means we're going to need to have all of our answers with radicals, not decimals. So use exact values. That's radical form, not decimal. To show the following are true. Okay? All right, suppose we have this here. Sine squared 60 plus cosine squared 60 equals 1, right? That's that Pythagorean. So according to that Pythagorean identity, this should be true, right? Well, let's check. All right, so what is sine of 60? Sine of 60, according to up here, where is it? There it is. Okay, sine of 60 is square root 3 over 2. Cosine of 60 is 1/2. Okay. All right, so let's fill that in. So sine of 60 is square root 3 over 2. Cosine 60 is 1/2. And we want to know, does this really equal 1? Well, let's see. Over here, square root 3, when I square it, I get 3. 2 squared is 4. 1 squared is 1. 2 squared is 4. Does this equal 1? I can add these two fractions. They have the same denominator. 3 plus 1 is 4. 4 over 4. Does this equal 1? Yes, it does. 1 does equal 1. It checks. Okay? What about this one? Sine squared 45 degrees minus cosine squared 45 degrees equals 0. Okay? Sine of 45 degrees, sine of 45 degrees, and cosine of 45 degrees, both of these are square root 2 over 2. Okay, so let's fill that in. Square root 2 over 2, square root 2 over 2. Does this equal 0? And yeah, we could already see it. But let's just multiply this out. 2 over 4 minus 2 over 4. Does this equal 0? Yeah, 2 minus 2 is 0. Okay. Okay, let's do another one. Let's let x equal 60 degrees and y equals 45 degrees. Simplify each expression as much as possible. Okay? All right, suppose that I have this one. 3 times sine x. Okay? 3 times sine x. So that's 3 times the sine of, what's x? 60 degrees. Okay? Sine of 60 degrees is square root 3 over 2. So here I get 3 square root of 3 over 2. And can't really simplify that anymore. Letter B, cosine of 2y. So that's cosine of 2 times y is 45 degrees. So that's cosine of 90 degrees. And cosine of 90 degrees, so this comes back from the first definition. This goes back to the first definition of the trig functions, the one that relates all of them to x, y, and r. So here, if you recall, this would be cosine is x over r at 90 degrees, and so this would be 0 over 1, which is just 0. Okay? And then letter C, 5 times sine of 3x minus 90 degrees. Okay, so we get 5 times sine, 3 times, what is x? 60 minus 90. So 5 times the sine of that is going to be 180 minus 90. So that's 5 times sine. 180 minus 90 is 90. And again, that goes back to the first definition of trig functions x, y, and r. Sine is y over r. Okay, so this is going to be 1 over 1, and that is going to give us 5. It's y over r. Okay, which is going to be 1 over 1. Okay, if you don't remember your quadrantal angles, like 90, 0, 90, 180, 270, 360, I'll write them down over here. So your quadrantal angles, and these should also be memorized, but these are the ones where I kind of memorized, but not really. I just visualize them. So either way, x, y, and r. Okay, so and because they really come from here, you have the unit circle. So right here, this is 1, this is 1, this is -1, this is -1. Okay, this is the x-axis, this is the y-axis. Okay, and we know that sine, if you remember, sine is y over r, cosine is x over r, and tangent is y over x. Okay, so here if we do sine of 0, cosine 0, tangent 0, sine are the y values. So at 0 degrees, right here, the y value is 0. Cosine are the x values. The x value here at 0 is 1. And tangent is just 0 over 1, y over x. So 0 over 1, which is 0. Okay, now let's go to 90 degrees. Sine of 90 degrees, cosine of 90 degrees, and tangent of 90 degrees. Again, sine are the y values. Here's 90 degrees. The y value is 1. Cosine are the x values. X value here is 0. And tangent is just y over x. 1 over 0, which is undefined. Okay. All right, and then now let's move to 180. The quadrantal angles are 0, 90, 180, 270, and 360, which is the same as 0. Okay, all right, so let's do sine of 180, cosine 180, and tangent of 180. Okay, so again, sine are the y values. The y values here are 0. Cosine are the x values. The x value here is -1. And then tangent is just y over x, so that's just 0 over -1, which is 0. Okay, and then let's do 270. Okay, at 270 degrees, which is down here, sine are the y values. The y value here is -1. Cosine are the x values. The x value here is 0. And tangent is just y over x, -1 over 0, which is undefined. Okay. Okay, so make sure you have all of these memorized. It's going to make the rest of the class flow a little bit better for you, because you're going to need to retrieve all of these answers relatively quickly. Okay, all right, so that ends part 2. If you have any questions, make sure you email me or text message me. And make sure you are keeping up with the homework on WebAssign, not on Canvas, on WebAssign.